Hello, everyone, and welcome to our next edition of the SCHOTT Pharmacity podcast. The topic today is identifying origins for glass breakage to optimize OEE in fill and finish. So we are talking about reduction of downtime in pharmaceutical fill and finish lines. And finally, about improving the yields in high-speed manufacturing of liquid pharmaceutical products such as vials, cartridges, or syringes. Today, I have with me two experts, Dr. Florian Maurer from SCHOTT and Franz Nada from SmartSkin Technologies. Good morning, both of you. I'd like you to ask you to introduce yourself very briefly to the audience.
Good morning. Hello to our listeners also from my side. My name is Florian Maurer, and within SCHOTT, the focus of my work is strength, reliability, and lifetime, and fracture analysis of pharmaceutical glass primary packaging.
And also hello and welcome from my side. My name is Franz Nada. I'm working for SmartSkin Technologies, and my field of responsibility is line optimization, customer services, and consulting.
Great, thanks for that. So to be honest, before the talk, I thought, wow, why do we need a 30-minute stop to learn about means for localizing origins of glass breakage? Shouldn't be this easier? Florian, what is it so difficult about it?
Well, glass breakage can be a complex topic. I could talk about it for hours or even days. But today, I will try to cover only the most essential basics to guide you through our intention. First of all, as a matter of fact, glass has a high intrinsic strength. But this high intrinsic strength is reduced by flaws and damages on the surface and in the volume of the glass. You can compare this behavior to a chain. When being pulled apart, a chain always fails at its weakest link. A strong chain then consists of strong, intact links, representing the high intrinsic strength of glass. Now, flaws and defects weaken the glass. In comparison to the chain, this would mean that weaker or damaged links are introduced. When being pulled apart, the chain now fails at much lower tension, and so does a flawed or damaged glass. It really breaks at lower mechanical loading because of its reduced strength. From my experience, the majority of glass breakage incidences in the pharmaceutical industry follows a two-step failure mechanism, which means that the failure-inducing flaw or damages are introduced prior to and independently from the application of the failure-inducing mechanical load. It is easy to identify the second step of the failure mechanism, the place where the failure-inducing mechanical load is applied, as this is the location on a fill and finish line where breakage is observed and the fragments are found. But it is much more difficult to identify the first step, the locations where flaws are created and damages are introduced, as these locations often are not obvious. So what actually happens is that the glass gets damaged and then carries these damages along the fill and finish process until application of the failure-inducing mechanical load. So to tackle glass breakage issues, it is reasonable to search for and reveal the damaging mechanisms on a line. And this is typically not where you find the shards.
Okay, I understand. So really not so trivial. So Franz, once we have a glass breakage, what is the consequence for a pharma production?
So, as Florian mentioned, glass is a strong material, but critical contact points, means of high pressure or shock or even like this, can lead to frequent glass breakages. So what will be the consequence? The consequence of glass breakages may occur loss of drug product, but also downtime for cleaning and sterilization of maybe an aseptic area or aseptic line. It will result in a drop down of the OEE. So you have unexpected low outcome, and it will also come to difficulty for production for schedule. So the frequency of breakage events depends on the line status and the proper setup of the total line. So it is mandatory to free your line from critical contact points, and that's exactly the point where we can help to fix these points.
Okay, I guess this is where your drones enter into play. So how can you help with your drone technology to facilitate the search for potential causes and to optimize the fit between the container and the line?
Okay, our drone technology is a detailed geometric replica of your container running in the filling line. Yeah, even it's a syringe, it's a vial or a cartridge. So we can exact measure the position where the shock or the pressure occurs on the surface of the container. We have about 19 to 192 sensors on the surface of the container, so we can in detail focus and locate the negative impact to the glass container. We can identify the spots of elevated pressure or dynamic effects, and we measure permanent the pressure, the rotation, the tilt, and the shock over the whole audit in the line. This will lead to root cause activities and can be focused on this identified hotspots. In general, higher pressure or shock may lead to higher risk of damages. After these audits, we can review the changes in the line and the effectiveness of these changes.
Okay. Which answer would be then still left open once we have applied the drone-based line evaluation, Florian?
Based on the drones, we only have information about potentially impacting spots, a hypothesis. To be sure that these identified hotspots are indeed affecting the strength of the glass containers, the hypothesis needs to be proven or to be verified before you start changing the adjustment of the line. It is common sense that if these changes come with higher efforts in terms of cost, downtime, or revalidation efforts, you cannot start large line modifications without having the proof that the identified hotspots are really an essential part of the issue. In particular, in the life-critical and thus highly regulated environment of pharmaceutical fill and finish environment, the execution of larger changes is tightly connected to risk management to avoid negative side effects introduced when executing substantial changes.
Okay, and how do you get this proof?
For this purpose, we recommend and offer a mechanical strength evaluation of the line monitoring, line analysis in terms of strength. We draw specimens before and after a potential critical spot and analyze them with regard to their mechanical strength. As a standard procedure, we fill the containers with water and then apply a controlled increasing hydraulic internal pressure until breakage. We call that a burst pressure test. The burst pressure of each container is considered as an individual strength value, and with the data we can estimate a breakage probability at a certain level of mechanical load for a particular set of containers. We then compare whether or not there is a change in breakage probability between samples that have passed the critical spot. By this, we are able to confirm whether or not this spot has any negative impact on the stability of the container.
Wow, amazing! What can be found with a combination of both technologies. So, Franz, this question would be then for you. You've mentioned in your talk that you will start a new on-site service which will combine your drone technology together with the glass analytics application, what Florian just explained. Could you please describe what is the typical procedure of such combined service?
Yes, of sure. So this is the first time we can combine and join forces from both sides, from the mechanical side for the line and from the other side for the glass. So we developed a 6-step process which can be adjusted on the needs of the customer or the project. Normally, we started with some pre-work. So we ask for some information about the issues of the line, of the general situation of the line. In the second step, that's the work on site. So we will visit both parties, SCHOTT and SmartSkin together, and have a walk on the line. We will also ask in detail how the handling is. Maybe we can do some trainings on site, but we will also do the inspection of the line in detail and investigate what is the situation and what might be the possibilities we can deliver there. We will do the audit. This means how I explained before, run the drone in detail. So we get on one side the technical thing. On the other side, we will together with the customer do the sampling. This means to set up a plan where we do samples and what we have to investigate in detail from this line. The next step will be an offsite analytics. This means just to do the reports, to do the analytics of the glass. Florian will explain in detail soon. And we will finish our conclusion and our reports. Then we will come back to the customers and discuss in a meeting the results on it. And we will execute corrective actions and discuss with them corrective actions. After these actions, we can come again. We can do a second step, and a last step, let's say, and do another audit where we see the results before and after the corrective actions.
Okay, thanks a lot for this explanation. Makes full sense. Florian, which kind of glass analytics are integrated into this joint service?
So the testing for mechanical strength, as described previously, is conducted at our accredited lab in Mainz, Germany. By this, we get a quantitative information about the strength and thus can confirm a process step that creates flaws and damages to the glass. Coming back to the comparison to a change, strength testing is capable to identify the weakest links. In a subsequent analysis, we examine the broken specimens in more detail by means of fracture analysis or fractography to identify the type of the failure-inducing flaw. This gives a qualitative insight about the nature of the flaw or damage. For instance, what type of contact damage led to failure. We also determine the axial position of the fracture origin, which reveals precious information about where the critical damage was introduced on the container geometry. For example, the heel, the shoulder, the body, the base, or the footprint section. But we also generate some first insights when being on site at the customer. We can already screen or inspect by means of optical microscopy for critical damages there on the container outer surface. From these screenings, a first impression about potential failure-inducing flaws is possible.
Thanks, Florian. Franz, what is the main advantage of usually being on site at your customer?
So the root cause are very specific. The full power of the different methods can only be revealed by full picture, scenery, and background of the situation on site. So we need a clear and transparent overview on line status and optimization potentials. In general, root cause is a teamwork and it requires the different expertises from all three main groups. This is the first step is best practice transfer on drone test design from working with many customers from our side from SmartSkin. But the next very important part is the unique expertise about glass things from SCHOTT. And we always want to combine and involve the production team from this special line because we need the experience of operators on site and to bring in all these activities from the operators.
In a standard strength test or line screening, we receive specimens from our customers and do all the work in our lab environment. In many cases, we do not get provided enough information about the background of the study. That's a pity because it limits us in supporting with our expertise. I often then have to write in the report, based on the information provided, no conclusion can be drawn. In contrast to that, when we are on site, we get much more insight into the infrastructure and can better understand the issues of the customer. This enables us to propose the right questions for designing an optimized study protocol. And the interpretation of the results can be much deeper and thus more beneficial for the customer. The joint service not only includes work from our accredited lab, like precise experiments and comprehensive documentation on a high technical and scientific level. On top of this, we can understand the issue or the problem immediately and in much more depth, leading to much more specific or tailored and thus more intensive support. So long story short, we can only realize our full competency and potential when we work together.
Great, wonderful, sounds very well. So Franz, is there further support you could provide moreover based on this service?
Yes, we can also help with assessing the effectiveness of potential changes. On the one hand, support in discussion of potential corrective actions and assistance to assess successful chance of change to more gentle glass handling. On the other hand, the verification of change efficiency after change execution by repetition of the execution testing to compare before and after the change.
Okay, so Florian, in conclusion, what is the benefit when interrupting the production schedule to execute these investigations for a pharma company?
Our approach is designed to fight the root cause of issues related to glass breakage. We strongly believe that this is a more sustainable strategy than only fighting the symptoms of glass breakage issues. If you are aware of hotspots on your fill and finish line and you start to eliminate them systematically step by step, this will for sure have a positive long-term effect on your yield. Therefore, if recurring breakage incidences occur, this requires multiple downtimes for cleaning and an uncertainty for the production time schedule. So why is it then not worth thinking about to get down to the root of the trouble? We want to support production teams to minimize or even eliminate downtimes due to breakage events.
Okay, so you've just said these hotspots in the lines. So Franz, what are typical hotspots? So based on your experience, are there different line design elements that often lead to troubles?
Yes, we see some again and again. We see issues or problem areas in the change of the transportation. One example is the transition from a mass conveyor to an individual transport. Another example is in the washing machine area, the transition from the mass conveyor to the infeed screw. Here is very critical, the transition, or in general, the transition from one dowel to another. These dowels have to be adjusted very well to avoid any critical areas.
Florian, could you confirm these observations?
Yes, definitely. And unfortunately, this shows to me again and again that there is a lack of knowledge or a misunderstanding about how to handle glass properly. Therefore, we offer training sessions, either included into the joint service activities or as a separate training to promote knowledge for proper handling and understanding the nature of glass, and even the fracture analysis of broken glass. This is meant to be kind of a support for capacity building for our customers.
Wow, very interesting. So, Franz, if we look into the future, besides the joint service with SCHOTT that you have now presented and are explaining to us, what can we expect to see from SmartSkin technologies?
Yes, beside the normal drone containers we can deliver for vials, cartridges, syringes, and or pen devices, we have developed a new calibration box to use on site. So normally the drones are calibrated from SmartSkin side for 6 months. but you can use the new calibration box on site for regularly confirmation of calibration if it's still okay. So you can use it for every day, every batch, or however the customer want to do it. This is also a key step to enable the GMP compliance. We will focus the next month on it. And it's also to prove the results that they will be valid, what you have tested on site in your line. Other developments are the neck crimping of the top load sensors. This is a detailed analysis of the crimping process and the harmonization of parallel crimping stations on a star wheel.
Wow, this sounds like exciting times coming up. So with this, I would say we're done. Thanks a lot for taking the time. Thanks a lot to the audience for hearing this podcast. Take care. Bye-bye.
Thank you. Bye-bye.
Bye-bye.